Hi all, in this one we're going to explore the concept of multiplicity for this expression x minus a to the n. We'll be focusing on odd multiplicity. So this is a video for those who are studying this in college, but also just for math enthusiasts because they kind of go into it in considerable depth. So let's begin with a blank slate, and first I'm going to take x minus 2 and I'm going to rewrite it as x minus 2 to the first. And notice that there's a red 1 in the exponent. So let's mark a number line. And then let's mark a point on the number line. Now, what is that point on the number line? Well, that is equal to the 2 that you see there in the same color, light blue, roughly speaking. The 2 is present because that is the root. In other words, if you take 2 and you plug it into x minus 2, it gives you an output of 0. Remember, that is what our root is. And now I'm going to grab a value slightly to the right of the 2. Take a look. So like 2.5. And I'm going to find the value of the expression of 2.5. That's equal to the following. 2.5 minus 2 to the first, but that is just 0.5. And notice something, that in this particular case, when you plug 2.5 in, what comes out is a number, but that number is above the x-axis. Here the x-axis is the horizontal line. And now let's repeat this on the other side. Take a look. Grab a value like 1.5. That's a value slightly to the left of the 2. And you plug it into the expression, take a look. What comes out? 1.5 minus 2 to the first is negative 0.5. So we've got 2 points, one above the x-axis and the one on the left below the x-axis. Take a look at the next one. We're going to do this a couple times. You got to see the pattern. So let's focus now on the expression x minus 2 and then cubed. Notice that the 3 is an exponent. That's an odd number. Let's take a look. So again, I mark my number line, mark the root, which is positive 2. Again, that's because if I plug that into the expression, I'm going to have 2 minus 2, which is 0. And then, again, I'm going to grab 2.5, plug that in, and let's see what comes out as the value. So I have 2.5 minus 2 cubed. That gives me 0.5 cubed, which then pops out as 0.125. That's a positive value, isn't it? It's smaller than the previous one, but it's positive. It's still above the x-axis. Then let's repeat this on the other side. So take a look. 1.5 goes in. What comes out is the following. 1.5 minus 2 cubed. That's negative 0.5 cubed. A negative number cubed is a negative number. So what comes out is a value below the x-axis. So as before, to the left we are below the x-axis. To the right we are above the. That is so because our exponent is odd. Just like in the previous one, remember, our exponent was also odd, wasn't it? Because it was equal to positive 1. That's an odd number. Let's exaggerate. Take a look. X minus 2 to the fifth. Same logic applies. You mark your root. You can make perhaps predictions about what I'm going to explain. When 2.5 goes in, what comes out is the following. 2.5 minus 2 is 0.5. 0.5 to the fifth is 0.03125. The point is that it's a positive value. Repeat that on the left side now. Let's see. I have 1.5 going in. Let's see here. 1.5 minus 2 to the fifth. So that gives 1.5 minus 2 to raise to the fifth. That gives negative 0.5 to the fifth, which is the negative 0.03125. What's important is that the number is negative. Again, as you can see, because our exponent is 5, that's an odd number. We're sticking with to the right of the root, the output is positive. To the left of it, it's negative. Let's do this one last time. Take a look again. X minus 2 to the seventh. The exponent is an odd number. Mark the root, which is positive 2. Grab a value like 2.5. Take a look. So 2.5 minus 2 to the seventh. You're calculating the value of the expression of 2.5. That gives you 0.5 to the seventh. You punch that into your calc, and it gives you an output that's very small, 0.0078125. The point is, though, that it's still a positive number, isn't it? But it's definitely smaller than in the previous cases. Let's repeat this again on the left. So 1.5 goes in. Calculate. 1.5 minus 2 to the seventh gives negative 0.5 to the seventh. Punch that into your calc, and it gives you that same number as above, but the sign is negative. And what is important, again, as you can see, is to the left of the root, the output is negative. To the right of the root, the output is positive. We don't care too much about the graphs. We just care about understanding what happens around the root, on the right side of it and on the left side of it. So it seems as though when the exponent on that expression is like 1 or 3 or 5 or 7 or 9 or 11, when it's an odd exponent, there's an output to the right of the root positive and usually one to the left of it negative. In other words, you might have heard the phrase that, for example, when you have what is known as an odd multiplicity, in other words, when in the exponent there you have an odd number, then the graph would cross the x-axis at the root. And this is a simple example of why. Because to the right of the root the output is positive, to the left negative, so you got to cross the root to go from the negative to the positive value, for example. And now let's also compare these. So this here is the graph of x minus 2 to the first. That's a possible output to the left of the root, and then this is a possible output to the right of the root. Again, the root is positive 2, where the graph crosses the x-axis. And now I already have x minus 2 to the first. That's the green line. But then I have another line that is a little more curvy, and that is x minus 2 cubed. Let's compare the outputs. So that green arrow represents the following. When, for example, about 1.2 is plugged into the expression x minus 2 to the first, it gives an output of about negative 0.8. For the red curve, it's a different value that's definitely, as you can see, closer to the x-axis. That's about negative 0.5. That's what the red arrow represents. It simply is the output of plugging approximately 1.2 into the expression x minus 2 cubed. Let's do this one more time. Take a look. You see? When you do this again, you see that for the red curve, it clearly is closer to the x-axis. On this side, where the arrows are shown, it's less negative, correct? Let's also do this one more time on the right side. On the right side, as you can see, that would be the value of x minus 2 to the first, but the red arrow is the value of x minus 2 cubed. And as you look at this picture, whether from left to right, right to left, it doesn't make too much difference, you observe that clearly the red graph is closer to the x-axis. So it goes at the root through the x-axis, but to the left of the root and to the right of the root, you see that it's closer to it. And that is so because of that exponent of 3. Let's exaggerate. Let's take a look at this one. So x minus 2 to the first is present as the red line. X minus 2 cubed is present as the red curve. And then x minus 2 to the fifth is present as the bluish curve, so to speak. And now let's see. That first green arrow represents the output of plugging a value into x minus 2 to the first. The next one, that's the output you get when you plug a value of x into x minus 2 cubed. And then that little arrow represents what you get when you plug that same value of x into x minus 2 to the fifth. So you see that as we go from 1 to 3 to 5 around the root within a little neighborhood, clearly the effect is as the exponent gets bigger, that the graph gets flatter. It gets pulled towards the x-axis. Let's repeat this one more time. Again, that's an output from x minus 2 to the first. That's an output from x minus 2 cubed. That there is an output from x minus 2 to the fifth. And as you can see, those blue arrows are quite short compared to the other ones. So in other words, again, as n, as the exponent increases in value, assuming that it's an odd number now, so when odd values of n increase from 1 to 3 to 5 to 7 to 9, you see that the graph gets pulled ever closer to the x-axis. In other words, changing the exponent through odd values of n flattens the graph around the root, the way you see here. So here's a kind of summary. So x minus a to the n, summary of main idea is essentially this. Assuming n is an odd number, not 2, not 4, not 6, but 1, 3, 5, for example. Assuming n is an odd number, as n increases, the graph flattens around a and stays above the x-axis to the right of a and below the x-axis to the left of a. That's the main idea. Thank you so much for watching. I hope it's been helpful. Please leave a like, and I'll see you in another video.